Hello, I'm Chelsea and I will be presenting about the introduction of silver in this presentation. So silver is a chemical element with a symbol of Ag and has an atomic number of 47. Silver is a transition metal since it is located in group 11, which is shown in the periodic table below. This part right here is the short summary for the introduction for silver.
Hi, I'm Christine Wong Jingwei and I'm going to present my part, which is the objectives. The objectives are: first, to study the physical and chemical properties; second, to study the bond that silver can form; third, to study about electron configuration; fourth, to know the structure of silver; and the fifth, to study the hybrid orbital and atomic spectra of arsenic.
Hi, Assalamualaikum. My name is Muhammad Iqbal bin Azri and I want to present to you about physical and chemical properties in argentum and the bond that argentum can form within its own element or with another element. For definition, argentum is a chemical element, a white lustrous metal valued for its decorative beauty and electrical conductivity. Having called argentum, which made the chemical symbol as Ag, located in group 11 and period 5 between copper in period 4 and gold in period 6. Its molar mass is 107.87 gram per mole and its atomic number is 47. Argentum is not a chemically active metal but will react to nitric acid and by hot concentrated sulfuric acid. Its melting and boiling point are so high, which are 960.8 degrees Celsius and 2212 degrees Celsius respectively, while its oxidation rate is only at +1, +2 and +3. Okay, silver metal will only react to elements in group 17 such as chlorine, bromine or iodine to form compounds like silver chloride, silver bromide and silver iodide.
So now I'm going to show you how silver ion looks like with the structure. And here are the two examples of low structure compounds with silver, such as silver nitrate and diamine silver nitrate.
There are two forms of electrochemical configuration, which are in neutral form and ionic form. The neutral form for the silver is quite long enough, so we can use the noble gas shorthand notation to write down the electroconfiguration, which is Kr(4d⁻10), 5s power of 1. For the ionic form of the silver, since there's the loss of one electron, so the electron configuration can be written as Kr(4d⁻10).
Hello, Assalamualaikum. So I am going to explain about the hybrid orbital. A hybrid orbital is an orbital formed by the combination of two or more atomic orbitals. The resulting orbital has a different shape and energy than the component orbitals that form it. Hybridization is used to model molecular geometry and to explain atomic bonding. The bonding scheme described by valence bond theory must account for molecular geometries as predicted by VSEPR theory. One example of silver hybrid orbital is AgNH3 2+. One s orbital and one p orbital of silver mix and undergo sp hybridization to form two hybrid orbitals which overlap with appropriate orbitals of two ammonia molecules. Hence, the hybridized orbitals used by silver in the complex AgNH3 2+ are of the type sp.
And I'll just share about the thermal conductivity of silver. So thermal conductivity is the ability of a metal to conduct heat energy, and silver has the highest thermal conductivity with the value of 430 watt per meter Kelvin, as silver's electrons are more free to move around compared to other elements. Next, I'm going to share about the atomic spectra of silver. So when atoms are stimulated, they emit light with specific wavelengths that correspond to various colors. The emitted light appears as a succession of colored lines with dark intervals in between, which is referred to as a line of atomic spectra. Therefore, the image that I've shown right now shows the atomic spectrum of silver. So, silver. It is sometimes referred to as a poor man's gold, and it has been unfairly consigned to second fiddle to its gleaming yellow counterpart, which is gold. But beyond its widespread use in jewelry and finance, the precious metal has a lot to give to the world. Silver has been proven to be one of the elements that contributed the most into building this technologically advanced era that we're comfortably living in right now. After everything that has been discussed throughout the video, we can see that how the physical and chemical properties of silver has made it possible for silver to become an excellent electrical and thermal conductor, making it ideal to be made into electrical appliances and other things as well, making it extremely valuable in today's modern society. So that is all from us, group 2, and this is the part A of our PBL chemistry video. That is all from us. Thank you.